Now our next engineering curve is spiral, and we have to study the Archimedean spiral in this chapter. So what is the definition of spiral? It is a curve traced out by a point moving in such a way that its movement towards or away from the pole is uniform with the increase of vectorial angle from the starting line. So here the point about which the line rotate is called pole, and the line joining any point on the curve with the pole is called radius vector. So this is one figure of spiral, and this is the starting point of the spiral. It goes clockwise and it will end at the center of the spiral, which is known as pole. So the rotation of the spiral is known as convolutions. Okay, and from center to maximum radii, which is the end of the spiral, two end of the spiral, one is minimum radii and another is maximum radii. So every Archimedean spiral has maximum radii, minimum radii and convolutions. So if we have three values, we are able to draw any Archimedean spiral. So in this curve, this is a pole or center of the spiral. This distance is known as minimum radii of the spiral. This is maximum radii of the spiral. And what are the convolutions? So if we draw like this, one 360-degree, another 360-degree revolution, and third 360-degree. So this spiral has three convolutions. Now take one example. Draw an Archimedean spiral of one convolutions, the greatest and least radii being 120 mm and 60 mm respectively. Draw tangent and normal to the spiral at any point on the curve. So here given data in which we have a maximum radii 120 mm and minimum radii 60 mm. So start by taking horizontal line. This is one center point O. Take OA and OB distance, which is 120 and 60 mm. Locate A and B. Draw vertical line from O. Now draw two circles here, which are concentric circle. Center O, one circle of radius OA 120 mm, which is R max, and another circle R minimum means minimum radii 60 mm. Now divide the circle into any number of equal parts. Here I have taken 12 number of equal parts. Now the difference between the radius of this circle, one is 120, another is 60 mm. So difference is AB, which is 60 mm. Now because we are using one convolution of the circle, and circle is divided into 12 parts, so the linear moment of the point of spiral is 60 mm during one convolutions, and that is 60 mm. So we have to divide this AB line also into 12 number of equal parts. First of all, we have to put the number on the outer circle 1 to 12. Now divide this AB line into 12 number of equal parts. Now P is starting point of spiral. Now when the point of spiral moves anti-clockwise, after 30 degree, it will at P1, means the point moves towards O one step. Now how to obtain P1 point? By taking O center, O1 radius, draw arc from 1 to up to O1 line, and this intersection point is P1. Similarly from 2 to P2, 3 to P3, 4, then 5, P6, P7, P8, P9, P10, P11, and P12. So every point will goes nearer to O during radial moment. So spiral has a two motions uniformly, linear as well as radial, and both are uniform. Now trace out all the points with curve P0, P1, P2, P3, P4 up to 12. So this curve is known as spiral of maximum radius 120 and minimum radius 60 mm. Now how to draw the normal and tangent? So you have to select one point S on the curve. Then find out the constant of the curve. So what is the equation of constant of the curve? It is difference in length of any two radius vectors by angle between them in radians. So if we take here OP, one radius vector which is 120 mm, and if we take another vector OP3, so what is the length of OP3? 105. And the angle between these two vector is 90 degree, means in radian it is pi by 2. So by equating these values, 120 minus 105 by pi by 2, we will get 9.55 millimeter. So this value is known as constant of this curve. So in normal and tangent we required constant of the curve. So select any point on the curve, then join S to pole of the spiral O. Then from O we have to draw one line which must be perpendicular to SO, and this line goes to towards where the radius of the spiral is bigger. So draw one line. The length of this line must be 9.55. Now from this end we have to join S with straight line. This line is known as normal at S, and perpendicular to normal from S it is tangent. So with using this method you can able to draw number of problems regarding Archimedes spiral if you have a maximum radii, minimum radii, and convolution of the spiral. Now at the end we must know the application of spiral curve. So here some applications are mentioned. One is clamping device of jig and fixture. So this is a clamping when we tied the screw, the change of the spiral you can see here, shape of spring of watch mechanism, profile cams for automation, and scroll plate which are used in lathe chuck. Okay, thank you very much.